Hi folks, so this is question 7. So first thing is it's a cylinder anyway, and the volume. So volume straight away, you know that it has to be pi r squared h, so it has to be that formula that you're using, and it tells you that the volume is 450 pi. It's 450 times pi. The radius, well, it tells you the diameter is 10. So the diameter of the cylinder is 10, therefore the radius of it has to be 5. So you can sub that in. So pi times 5 squared h equals 450 pi. And then it's just a matter of cancelling out and moving over. So you can cancel out those pi's because there's a pi being multiplied on both sides. So 25h equals 450. Therefore move over to 25 and divide it. H equals 450 over 25, and then you should get 18. So h is 18. So h is 18 centimeters. So that's part A. Right, so part B then, obviously they're in the shapes of cones, and there's a volume mentioned here. So it has a volume of, so a large candle has a volume of 150 pi, the small one has the value of 12 pi. So small cone and large cone. And we're going to be using the volume of a cone formula then. So that's 1 over 3 pi r squared h. So let's just put in what we know so far. So 1 over 3 pi is just going to be pi. Then r, so the radius of the small circle then, so it says that the large one has a radius that is k times that of the smaller one. So we'll just leave it as r squared for the minute. We don't really have any information about the radius of the small one. And then the height of it is going to be just h. So the height of the small candle is just h. So we're going to get h. So all we can do is put in r squared and in h and h for that, and that is all going to be equal to 12 pi. Right, so let's keep these separate. The large one then, so it's going to be 1 over 3 pi, and then it tells us a little bit of something about the radius. It's k times that of the small one, so it's going to be k r squared. So the radius of the large candle is k, or it's k times whatever the small one was, and then h, it's twice the small one, and the small one we called h, so we're going to call this 2h. And all that then has to be equal to 150 pi. So we're kind of doing two equations at the same time then. So let's just concentrate on the small one anyway. The 2 pi's will cancel out because you've got a pi being multiplied on both sides. So we're left with 1 over 3. Actually, I can bring over the 1 over 3 as well. So if 1 over 3 is being multiplied, so if you bring over 1 over 3 and divide it, it's going to be the same as 36 on the other side. So 36 equals r squared h. And then for the other equation, you can cancel out the pi's as well. There's a pi being multiplied on both sides. If you bring over the 1 over 3 and divide, so 150 divided by 1 over 3 is the same as 150 times 3, so that's going to be 450. So 450 has to be equal to, let's put all these together then. Well, you've got 2 k squared r squared h, and you can bring over that 2 actually, so 450 divided by 2 should be 225. Okay. Let's just use the information then from the first one and put it into the second one. So we know that r squared times h is the same thing as 36. So r squared h is 36. Therefore I'm going to take this r squared h in here and I'm going to put a 36 in instead of it. So k squared times 36 has to be equal to 225. Or in other words, 36 k squared is equal to 225. Then k squared, let's move over to 36, equals 225 over 36. And you might spot then that those two numbers are both square numbers. So all you have to do is you have to do the square root of 225 and the square root of 36. So you should get 15 over 6. Square root of 225 is 15, square root of 36 is 6. So 15 over 6, that's what k is. Right, so then for part C, it's split up pretty much into two different parts. So you have to find the length of the arc from B to A first. So there's a formula for that. So all you do is you have to find the length all the way around here. And that's going to be whatever the angle at the centre, so in this case it'll be 216 over 360. So that's the proportion of the circle that we're looking at, times, and then you could times it either by 2 pi r or by pi d, pi times d. So there's two different formulae that different classes use. So we'll just use 2 pi r. I think that's more commonly used. So the theta part is the 216, that's the angle at the centre of what we're looking for, over 360 times by 2 times by pi times by the radius, which is 8. So from O to A is 8. And then it's just using the calculator to put that in, and it gives you 9.6 pi. So the answer, it told us to leave our answer in that form. The second part then, hence find the radius of the cone. So from B to A, so that arc that we've just found out, if you imagine that that's the point at the top of the cone, so if you were to make that picture there, or that kind of whatever shape that is the part, if you were to kind of push up that O and make a cone with that, then from B to A has to be the full circumference of the circle. So the point B would meet the point A then, and the point O would kind of go up in the air. So that would form the cone. That's how you'd make the cone from that net. So therefore, what you've just found out, that 9.6, that has to be equal to the full circumference of the cone. Okay, so the circle at the bottom of the cone. So that has to be equal to 2 pi r. Sorry, it was 9.6 pi. So that has to be equal to 2 pi r. So then the pi's will cancel again. And then it's just a matter of dividing. So 2r has to be equal to 9.6. So it's just a matter of dividing by 2. 9.6 divided by 2. So that's 4.8. So that's the final answer then. So part D then, the first part's simple enough. It's just a sphere, so 4 over 3 pi r cubed. So that's just the formula from your log tables. Again, that's how you work out the volume of a sphere. So 4 over 3 times pi times the radius is 2.7, and we have to cube that as well. So we should get 82.448 centimeters cubed. So let's just put that into the calculator then. Right, so for the next part, there's a slice cut off the bottom, so there's a circle then at the bottom, so it's like there's a kind of a circle all the way around at the bottom. So I'm going to try and find the radius of that circle, so that would be from there to there, that's that black line I've drawn in. So I'm going to try and find that. So I know the circle at the bottom then is pi r squared, that's the area, and it tells us the area of the circular base is 5.4. So r squared then has to be equal to 5.4 over pi, whatever that is, and then r will be the square root of all that, so 5.4 over pi. So you can use the calculator for all of that then, and you should get 1.311058. So that's what I'm getting for that part there, 1.311058, and I'm putting in all those decimal places because I want to keep it as accurate, because I have to use that figure again then, so I want to keep it as accurate as possible. So I also know, if you look back to the last part, I know that the radius of the sphere, so the radius of the sphere is 2.7, so we used that before. So therefore, if you imagine the kind of center of the sphere without the bottom being cut off, that would be there. So this has to be 2.7 up here, and we also know that this part down here, because that's just the radius of the sphere as well, that has to be 2.7 as well. So you might be able to spot then that we've actually just got a right angle triangle. So we'll call this bit x here. So what we're asked for is to find L, that's the vertical distance, so that's all of that there. So we're asked to find that, but we know that from the top down to the center is 2.7, so we just need to find that x, what I've marked in x there. So it's just Pythagoras, it's 2.7 squared minus 1.311058 squared, and then the square root of all of that. So that has to be equal to x. So I'm getting 2.36 there. So that's equal to x. So that's in centimeters then. And then I'm just doing 2.36 plus the 2.7. So I'm doing this bit here plus the rest of it. So plus up there. So that's 2.7. And I'm getting 5.06 centimeters. That's rounded off as well. And that's the same thing then. That's centimeters, and they want the answer. It asks is there just that's an easy thing to overlook. It asks us for it in millimeters, so that's the same thing as 51 millimeters. So if you round it off, so 51 millimeters, that's our final answer. Right, so for part E, it gives us a lot of information anyway. So the length of all the sides are 30, and it tells us that E is the midpoint of AB, so therefore this has to be 15 here. This has to be 15. And it also says that F is a midpoint. F is the midpoint of AD, so that's 15, and that's 15. Also, we know that because of that, the lines EC and FB, okay, they meet at 90 degrees. So each of those angles in there is a right angle. So all of those angles around that circle are all right angles. So we know that as well. So what we're going to be doing is we're going to be using similar triangles. So it says it there in the question anyway. Find the length of EO. So it's this one here that we're trying to work out ultimately. So we're going to show that two of the triangles are similar. So we're going to use the triangles, this one here, EBC. So we're using that triangle, so triangle EBC. And triangle, the little one, so this one here, EBO. So EBO. So those are similar. And we have to show why they're similar. So we have to show that each angle corresponds to an equal angle. So the angle, let's take the right angles, because each of them have a right angle, don't they? So the angle EBC in the big one is equal to EOB. So EOB. Because so both 90 degrees. And then well, this angle here is the same angle in both triangles, isn't it? It's in the small triangle it's BEO, and in the big triangle it's BEC. So those two have to be equal to each other. So BEC has to be equal to angle, should have my angle in there as well, it has to be equal to angle BEC, because it's the same angle. And then the other ones then are BCE so the angle BCE is the other one in the big triangle, and EBO because, well, they're just the other angles then in a right angle triangle, so they have to be the same, because the angles right angle, because every triangle has to, the angles have to add up to 180. So the angles add to 180 degrees. So that's the reasons why those two triangles are similar, because you've matched an angle in each of them. So if you're thinking about the two triangles then, so EBC will be this one. If you're just trying to draw them out separately just to show. So EBC, and then the other triangle, the little small triangle, if you're to kind of flip it around and put it the same way, then I'll draw it smaller even just to show. If you're kind of changed around the orientation a little bit, so the O would kind of come down here. If you think about it, if you're kind of flip it around, and then the B would be kind of along the bottom of it then, so it would be here, and the other one, the E, would have to be up. Yeah, that makes sense. So E has to be here. So you just kind of flipped it around to so that they kind of match. So look up the big one then, and let's fill in the side. So this has to be 30, and this has to be 15. That's the same. You're just kind of, the big one, you're just kind of lifting it down. And we don't know what the hypotenuse of that would be, but we might not need it. The other one then, the long side of the EOB is 15, isn't it? The long side of it, because it's out here. Now let's just use the fact that they're similar triangles. So we want, the question was to find the length of EO. So we want the length of EO. So we're going to put that in anyway. into an equation then. So the length of EO over, say, the length of EB, because we know that the length of EB is 15, and we can put that in a second. That has to be equal to the same as, so corresponding then in the other triangle would be EB length of EB over EC over EC. So if you look at, we actually don't know what EC is, but we can figure it out easily enough. So I'm going to use Pythagoras. So I'm going to do 15 squared plus 30 squared, and then square root of that, and that would be what EC is. And that's 33.541. So we know that, so that's the length of EC then. So we've just used Pythagoras, used the fact that it's a right angle triangle. So let's fit everything in then. So the only thing missing, the only one variable then is the EO. So we don't know what EO is yet, but we should in a second. So EO over what EB is, so EB is 15. That has to be equal to EB again is 15 over EC, and that's the 33.541. So all you need to do then is you just need to bring the 15 across and multiply it. So EO is equal to 15 over 33.541 times by 15. And then you can just use calculator for that. And then actually I just spotted there in the question it asks us to give it the answer in the form of roots. So instead of 33.541, like I put in there, that in third form would be 15 root 5. So let's just put that in instead. And then that should help us to get our answer in the form that they want. So if you put all that in the calculator together, you should get 3 root 5. And then centimeters. So that's it. That's everything then for all of that question.